everyone. So today we're looking at, in your notes, solving equations involving logarithms. And there's a couple of different types of equations that can be solved using logs. We're focusing just on how to get an x out of the exponent. And if you remember back to the first half of this chapter, that was a pretty major issue for us, is that when we had a number that we wanted to put in, like, let's say we had the equation y equals 13 times 2 to the power of x. And I wanted to know, when will this value reach a particular number? When will this value cross 100? Something like that. We had to kind of imagine plugging a number in here, and then we had to go in our calculator and look in the table and just get as close as we could for x. So what we're doing today is really focusing on how to actually calculate that x value if I put a number in right here. Okay? So I'm going to kind of glaze over the fill in the blank stuff. I just want to jump into this example, and I'll kind of hit these things as I'm going through the example. So the first thing I need to do is get just the exponential part of the equation by itself. So that would be like the something to the power of something, okay? Which means in this example, the first thing I need to do is get rid of the 5. So I'm going to divide by 5, and I get 3 to the power of x equals 12. So really what I'm asking now here is, what exponent turns a 3 into a 12? Well, we don't actually know, okay? Because 3 to the second power is 9, and 3 to the third power jumps all the way to 27. So it's somewhere between that 2 and that 3, okay, because it's somewhere between 9 and 27, but I don't know what number this actually is. So it really would be nice if I could get that x down into my problem so that I could start solving with it. Well, the good news is there is a way to get that down, okay? And so what I'm going to do is I'm going to take a common log of each side. So I'm going to take a common log of 3 to the x and a common log of 12. And the reason I chose a common log is because that's the one the calculator will do for us. All right, the calculator will do a common log. And if you think about your rules of exponents, if I have log of 3 to the x, okay, equals log of 12, this right here is an exponent, and I can pull that down in front of the log, all right, using those properties we talked about before. So now I have x times the common log of 3 equals the common log of 12. Okay, so I took a log of both sides and I moved the exponent down in front. Now what I can do is now this x is down in the main body of my problem, which is the whole thing I wanted to do. Now this is connected with multiplication, so I can get rid of it by just dividing by log of 3. And divide by log of 3. So this cancels, and now I just need to evaluate this, but I can do this straight in my calculator. Get a calculator out here real quick. My junky one, but so I can type this in as log of 12 divided by log of 3. Okay? And I get 2.26. And that's about what we estimated, right? Because we had said back here when I had 3 to the x equals 12, that if this was a 2, 3 to the second power would give me 9. And that's awfully close. We needed it a little bit bigger, and that's what this 2.26 does. If I check it, 3 to the power of 2.26 gets me awfully, awfully close to that 12. Had I kept a little longer decimal, it probably would have been even closer. And if I put it back in the original one, 5 times 3 to the power of 2.26 brings me awfully close to 60, which is where I should have been. Okay, so that's kind of your general strategy, is get it to where you just have an exponential piece. Take the log of both sides, slide the exponent down in front, and divide away your logs. Okay, so let's try a couple of those. So looking here under the examples, 6 to the x equals 34. I apologize in advance. Some of these I may have to move out here where I have some empty space to fit them in. Okay, so 6 to the x equals 34. I don't have anything else to get rid of here. So I'm going to start right away by doing a log of 6 to the x and a log of 34, a common log of both sides. Okay? And then, because this is an exponent, I know I can put it down in front of the log. So I'm going to write this as x times the log of 6 equals the log of 34. And then I would get rid of my log 6 by dividing by log 6. Divide by log 6. This cancels, and now I just need to do this division in my calculator. So log 34. Just make sure you close the parentheses after that first log, otherwise you're going to get a wrong answer here. And divide by log 6. Enter. Can't really see because I have a weird spot on my calculator. I get like 1.97 as an answer here. Sorry, it's going to be all over the place. X equals 1.97 as an answer. Okay. And if you think about whether or not that's reasonable, I'm asking 6 to what power gets you 34? This is awfully close to 2. 6 squared would give me 36, so that would be just a little bit bigger. Okay. So that is my answer, x equals 1.97. So looking at this next one, 7 times 8 to the x equals 57. First thing I'm going to do here is divide by 7, because I have to get rid of anything else besides the 8 to the x. So now I have 8 to the x equals, this is going to be an ugly decimal. Okay, I end up with like 8.143. Okay. And then again, I would probably take, just so you can see what I'm doing, I'll switch colors here, the log of both sides and slide the x down in front. So I have x times log of 8 equals log of 8.143. And then to solve, I'm just going to divide both sides by that log 8. So I'm going to do log of 8.143. Whoops, I missed my decimal point. Divided by log of 8. I come out with like 1.01. Which again makes sense because 8 to the first power would give me just a regular 8. So it's going to be just a little bit bigger than that. X equals, whoops, what did I say? 1.01. Okay, so there's my answer for that second one. So really the only thing that gets to be a little more complex is how much stuff you have to do to it ahead of time before you do that crazy log thing. Okay, let's look at this next one. This next one is tricky just to get it into the right form, and I hope you can follow me because I have a feeling I'm going to jump over to the other side here. But so I need to get like this piece of it by itself. So I first need to start by thinking about what do I need to get rid of here. I would probably start by subtracting 15. Minus 15, minus 15. And so now what I really have is 4 to the x over 5 equals 20. And then to get rid of that 5, that's division. So I would multiply by 5 and multiply by 5. Okay. And so now if I go over here, I'm probably going to jump all the way to here. Okay. Sorry, I know that's going to be hard to follow. 4 to the x equals 100. And when I get to this point, this is where I do the log and the log, move my exponent, and I have x times log of 4 equals log of 100. Okay. Divide both sides by log 4. Divide by log 4. Okay, log of 100 divided by log of 4 gives me 3.32. And that's my answer for this one way back here. Okay, one more to go here. Don't let this mess throw you off. We're going to start it the same way we've started every other one. So I'm going to start by subtracting 23. Subtracting 23. And so now I have 3 to the power of 3x minus 2 equals, let's see, 42, I believe. Now, this might freak you out because it doesn't look like all the others, but I can't really do anything with it until I bring it down into the main body of the problem. So I'm going to take the log on both sides at this point because I'm down to the point where I have 3 to some power. Okay, so I'm going to go ahead and take that step. And I'm going to take this whole exponent and move it out in front. Okay, so again, I'm going to move this over here. And so now what this says is 3x minus 2 times log of 3. And again, that came from moving this exponent down in front of the log 3 equals log 42. And again, to get this by itself, because I'm going to need this by itself before I can solve, I'm going to get rid of log 3 by dividing by log 3. Divide by log 3. Cancel. And so now I have 3x minus 2 equals, this part's going in my calculator, so log 42 divided by log 3. I end up with 3.40. And now from here, I'm going to pretend all this other mess does not exist, and now I just have a two-step equation. Okay, so like from here, I would plus 2 and plus 2. I know this is so messy. I'm so sorry, guys. 3x equals 5.4. Divide by 3, divide by 3, and I believe I get 1.8. The final answer there. Okay, let me just double check that. Yep, 1.8. Okay, so name of the game is get the exponential piece by itself, take the log of both sides, slide the exponent down in front, and then divide to get rid of your logs. And then if you do have any steps left over, like if you aren't just done, all these other ones we were done because we were down to just x at that point. Like here, when I divided by log 4, I was left with just an x. In this one, I was down to a 3x minus 2, so I had to keep going. Okay? Okay, that's it for me today. You should have a homework assignment in your packet. I forget exactly what it's called, but probably something like solving exponentials. That's all you've got to get done today. Okay? And we'll talk about this in class on Friday if you are still confused.